What I would like to share with all the participants here is coming directly from our project that is still ongoing. It represents one of the example that how ADPC brings space application, space data, or Earth observation data to help activities on the ground. My name is Peeranan. I'm the director of the Geospatial Information Department of ADPC. ADPC is an international organization based in Bangkok, but we work regionally, covering the entire Asia and a little bit of the Pacific island region. Our mandate is really to support the government and non-government stakeholders to manage disasters. And the recent intervention that I want to talk about today is that we brought over science and technology, especially Earth observation technology, to address and help governments address the disaster management activities in a much more effective way. And this is part of the global initiative started by the US government and through USAID and NASA. And the main aim of that program is to establish a global network of hubs, geospatial hubs, and what they call severe hubs. In our region, we work with what we call severe Mekong, which covers the 5 lower Mekong countries, starting from Myanmar, Thailand, Laos, PDR, Cambodia, and Vietnam. And the goal is very simple. The goal is to bring Earth observation data to help address demands on the ground. And the demands, most of the demands that we have heard from this region would be to handle disaster situation in a much more effective way, starting from pre-disaster, during, and even after disaster. And at the same time, as Augusto mentioned from the beginning, partnership and network is a very important aspect of this project. So while we are directly helping specific governments, we create a network of learning for one government to share with the other governments, or from experts from universities to share knowledge and know-how to users and practitioners. So that is basically what we are trying to achieve. And one of the things that we have been doing is related to how we use EU-based space data to address flood risks. And the example that I would like to share here, this is just one of many examples on the work that we are doing. This is called Hydra Floods. Right? The full name of it is Hydrologic Remote Sensing Analysis for Floods. And let's look at it together. Where did that start? It started actually from our conversation with the National Disaster Management Organization in Myanmar. The problem that they faced with was how they would address flood emergency response and relief better. They have access to international charters such as the Sentinel Asia in Asia, as well as the International Charter for Disaster Management. So they can access, they can request satellite imagery and analytics for them to use to respond to floods on the ground. The problem that they faced with was that it took some time for the data to come in, to be processed and come in and reach that department, counting also the internal bureaucracy to get approval within the government to make the request. So they were wondering if there was any way to get a much quicker data, may not be as high resolution or may not be as accurate as what they can get from the international charter, but something very, very quick for them to take action on. That's where we try to develop something to help them. And the basic idea behind this work is to give users, non-technical user, an ability to access flood extent map on a near real-time basis, almost on a daily basis, for them to know where the flooding areas are, and then they can take action very, very quickly. So that's a basic idea, and that does not stop them from making a request to the international charter to get even a better set of data to verify and take more detailed action later on. So how do we do it? Actually, let me talk about the challenges first. When we were talking to the Myanmar government about this work, we realized that there were many challenges. Right? First of all, water extent map, flood extent map can be achieved or obtained by many institutions. But then that led to confusions by the government, in that case was government of Myanmar, because they did not have enough technical understanding on the different kind of data or the different methods used. They would like something quick that aggregate all the data or just tell them which one to use and then they can take action on. Moreover, there was a little bit of limited information on how the information was generated. And a lot of information was generated and provided to the government, but in order for them to defend it, to tell their supervisors why they chose this map, they need to know how they were developed. So, but that kind of information may not be always available in the emergency situation. And as some of you know already, in our ASEAN region, during the rainy season, cloud cover is a big thing. And cloud cover really prohibits optical imagery from reaching the ground and deem those optical sensors useless for flood extent mapping. So that was a major problem. They also had an issue on the volume of data that we have to keep feeding to them. And sometimes if they want to store those data into their own server and process it later, the government will not have that ability to do so. So these are some of the challenges that we face with. So we came up with a solution to address those challenges. One is that we try to make everything open. The source code of HydroFlood is open. We try to document all the processes, the assumptions made behind the methodology, and even the methodology itself, we document them. We publish them on a peer review paper. We overcome the big data challenge by putting things on the cloud. Right now, using Google Earth Engine and also Google Cloud ecosystem to address that. And then last but not the least, to overcome this problem with data not being available at the time of the need, we leverage multiple sensors and combine them into a combined flood extent map for stakeholders to use quite easily. So I will go skip this one. I can tell you here that we use from the European Space Agency, use Sentinel-1 and Sentinel-2 data. But as I said before, it was not a standalone product. We fused the product, combining not only the optical data, but also radar data from Sentinel data, and combine them together and create a composite flood map that we thought as the best for the day. And that was transferred into the server for our stakeholders to use. So quickly, let's go to the methodology. I know the time is limited, so I will go very quickly on this one, but I have already expressed my willingness to the organizers that my slide can be shared. So you can access to the slide at the later time. Let's talk about optical mapping. When everyone loves optical data, it's easy to process. But the problem is cloud. As I said before, this is one of the example of an optical image of the area in July in Myanmar. It's almost impossible to use or to bring about any useful information from this image. So we supplemented the optical imagery with SAR, which has an ability to penetrate cloud and looking at the ground and distinguish the surface water and the other land cover types quite easily. But SAR also has its own limitation, right? Sometimes it's hard to distinguish some smooth surfaces that may look like water. So how do we actually overcome that? when we started the process, we used SAR and we got some misinterpretation quite a bit. So that was overcome again by introducing a machine learning algorithm, right, to train our model to distinguish, to detect surface water, make differentiate it from the other surface type. And it took time for our model to learn, but at the end, we were quite happy with the result, and we are now able to automate the detection of surface water using both SAR and optical data. And as I said before, everything that we did on hydrofloods was totally open. So the source code is open, the source code is accessible to anyone. And I'm not sure if the address of the GitHub is here, but if not, you can reach out to me later. My email address has been shared. Reach out to me and I can share you the location of the source code. Again, also documentation was along the line. We made comments in the code, but also we have separate documentation to describe the process on how we can do this. We talk about separate sensor data, right, from SAR to optical, but then for stakeholders, if we provide them with different maps, they will be still struggling on how to deciding on which one to use. So we make one step further to fuse the different sensor data together and create one wall-to-wall map for stakeholders to understand it quite easily and to be able to use it quite easily. And the workflow of this data fusion is we start with Landsat 8, Sentinel-1, Sentinel-2, and VS data. It goes through all these processing image, but at the end, the final product will be just one map, right, combining data from all 4 satellite sensors. And that one map is the best that we can get out of these 4 data on a particular day. And that one map will be transferred to stakeholders for them to take action. Realizing that there will be uncertainty in this new method. And this uncertainty sometimes is very important for the stakeholders to understand and be able to convey to their superiors. So we did our own measurement of uncertainty and communicated to the stakeholders to make sure that they understand that nothing is 100% correct. But with the bound of certainty, the confidence that we can make, they can be quite confident in taking actions. And we hope that this confidence interval will be improving as we get more and more data to feed into the machine learning model. So this project is not a scientific project only. Right? The focus is really on how we can bring science to good uses by the countries. It was not so fortunate that Myanmar had to go through a problematic situation at the moment, so we could not continue the engagement with Myanmar. But then the same methodology was used in Cambodia. Right? We work with the World Food Program in Cambodia and deploy these hydrofloods to provide Cambodia with flood extent map late last year. And to our surprise, good surprise, the map was used for humanitarian effort in the country. The map was disseminated very widely on flood bulletins to people, not only within the government, but also non-government. And that work was acknowledged by the WMO report, the 2020 State of Climate Services report late last year. Our partner also tried the methodology to take one step further to not only look at the flood extent, but take it all the way to estimating the impact. And this is the work done by our technical partner, Delta-RES, in Europe. They took these hydrofloods and overlaid it with the network of roads, and then estimate the vulnerability and damage that the flood can cause on different segments of the road, and use that to inform the stakeholders I don't know where they was applied, but it was used to inform the stakeholders to estimate the impact and the disruption that the flooding could cause in the city. So just to conclude, hydro floods, what does it provide? It provides a daily wall-to-wall maps in a pretty high resolution, as high as 10-meter resolution, spatial resolution of estimated surface water. And that has been proven to be useful for disaster emergency management responders in Cambodia. We hope to try to test it in Myanmar when the situation is better. And now it's being expanded to other countries, including Vietnam, Laos, PDR, and Thailand. And we'll be happy to talk to Gista. Gista also has a very up-to-date and nice, almost daily flood extent mapping. We will be happy to cross compare the two results. There are limitations on this product though, right? So given that we are using satellite observation for something like flash floods or dam breaks, that water comes and goes very, very quickly within hours, satellite cannot capture that. Satellite may be, if we're lucky, satellites may be able to capture some of it, but I'm sure that it will miss a lot of events. So that was made clear to our stakeholders that for something like flash floods and or dam breaks that happened in Laos, PDR a few years back, this may not be very, very useful. So as I said before, this is based on models, so there is still a little bit of uncertainty and error that we are observing. So at some point, in some different types of terrains, we still see that the satellite-based automated water maps may not be exactly as what has been observed on the ground, but we are working very hard with our partners on the ground to collect more information for us to train the model and improve the model, and eventually we hope that this accuracy issue will be gone and we can be very confident in using this product. And with that, I will conclude my presentation. Thank you very much.